I've been messing around with my new solid-state Tesla coil driver, the Mighty Ramp. This is the unfinished board from the manufacturer, missing a few ICs and some other headers. It's only 60 by 60 millimeters, which is pretty small. And I plan on doing a more in-depth video of this in the future. However, I just wanted to show what I've been working on today. So we have the driver over here. It's being powered by a Variac running at 120 volts AC. This goes into a voltage doubler over here, this bank of capacitors. This is 8100 microfarads total, and that feeds into the half bridge over here of IGBTs. We have secondary feedback as well as current sense for overcurrent protection via another CT. For most of my testing, I've been using this larger 4-inch secondary coil. It has a pretty big top load on it, and with 3 turns at 120 volts AC, 340 volts DC, I've been getting 30-inch arcs, which seems to be around the max arc length that you can get with the half mains ramp time. Today I've been messing around with this smaller secondary coil. Both of these coils have an outer shell that's filled with epoxy. This coil, the secondary winding, is only 1.4 inches tall. It's wound with 44 gauge magnet wire. And I've also been playing around with this internal primary. So this primary is wound on some unknown powder iron cores. Typically this is done with ferrite. It only has 4 turns. And I'm using some spare 3D printed parts here and some tack to kind of hold everything in place at the proper height. So we've got everything set up here now, and I'm going to power on the coil. And I wanted to show off how straight these arcs are. So this is about 23 inches. They get a little shorter when I turn the pulse or the BPS up a little bit. That's full voltage. So after that run, the secondary coil is pretty warm, probably due to the epoxy. Here you can see the primary coil down here. It is not very warm at all though, which is good. That was about 83 amps of primary current. Down here, I have the DC blocking capacitor. This is 0.33 microfarads. This does help to increase current a little bit in the primary coil. However, it's not close enough to be resonant. Here is the half bridge over here. I do need to rebuild this and add a bigger heatsink. This little heatsink doesn't quite cut it, so I have a fan blowing on it right now. Here is the Mighty Ramp driver. The overcurrent protection on this has been amazing. I've probably had hundreds of flashovers as well as overcurrent trips, and I still haven't destroyed any IGBTs. I do plan on doing a follow-up video on this project with a lot more information, as well as releasing all these files so that people can build this driver as well. I'm also working on a through-hole version of the Mighty Ramp that's more beginner-friendly, that also contains the half bridge as well as the doubling capacitors and everything else that's required. So make sure you check out my videos in the future. Thanks for watching.